Welcome to this video lesson. Today we will be looking at angles between a line and a plane and angles between two planes. The two main ideas before watching this video would be plane introduction and dot products. We're going to start off by talking about the angle between a line and a plane, and we're going to do that through a diagram. We're going to have a plane and we're going to have a line going through it, and we're going to call this line W. We're going to use the normal of the plane to come up with the equation. So we're going to draw a normal to the plane, and the angle formed between the normal and W is going to be theta. We know that the dot product between n and w will equal to the magnitude of vector n times magnitude of vector w multiplied by the cosine of the angle between them. So the cosine of the angle will equal to the dot product divided by the magnitude of vector n times magnitude of w. To get the acute angle, we want the absolute value of this because cosine of theta needs to be positive in order for us to get the acute angle. Now we have come up with an equation that can help us find the angle between the normal and the line, but we need an equation that can help us find the angle between the plane and the line. Let's call this angle phi. Now the distance from the plane to the location where the line touches the normal can be calculated by sine of phi because that side is opposite to that angle, and it can also be represented by cosine of theta because this side is adjacent to theta. We can replace cosine of theta by the expression that we got above, meaning that sine of phi, which is the angle between the plane and the line, is equal to the magnitude of the dot product of vectors n and w divided by the magnitude of vector n and magnitude of vector w. Here, vector w represents the direction of the line, and vector n represents the direction of the normal to the plane. Now let's look at the angle between two planes. So we're going to have two planes. We're going to call one of those planes pi 1 and the other plane pi 2. And we're going to use the normal to these two planes to come up with an expression for the angle between them. We're going to redraw the three-dimensional planes there as two dimensions. So we'll have pi 2 just going horizontally and pi 1 going on an angle to it. And we're going to draw the normal to pi 1 and normal to pi 2. And we're also going to label the angle between them, and we're going to use the acute angle here, and we're going to label that as theta. Note that we have formed a quadrilateral here, right there in between, and the angle shown there, the obtuse angle, is 180 minus theta because we got a straight line there. And we got two other angles there which are both 90. And the missing angle there is going to be 360 because it's a quadrilateral, minus 90 from the two perpendicular lines, minus 180 minus theta, which is the obtuse angle, and that gives us theta, meaning that the acute angle between the two planes will be the same as the acute angle between the normals. We're going to use this to come up with an expression that we can use to find the angle. So the dot product of n1 and n2 is equal to the magnitude of n1 times magnitude of n2 times cosine of theta. And cosine of theta can be calculated by the dot product of n1 and n2 divided by the magnitude of n1 and magnitude of n2. And we're going to use the absolute value for the dot product in order to come up with the acute angle between them. Note that we use the normals to the plane because the Cartesian form of a plane conveniently gives us the normal to the plane, and we can just use those components and use their dot products and magnitudes to find the angle between the two planes. Note that if two planes are parallel, that means their normals are also parallel, and that means the angle between them are either 0 or 180 degrees. In this case, we are going to use theta is equal to 0 because we are only calculating the acute angle using this equation. The summary of the concepts to this video is fast forwarded here. So if you want to pause and write down any of the information, please feel free to do so. And now we're going to look at an example. Okay, in this question, we want to determine the angle between two planes, pi 1 and pi 2. Pi 1 is given in Cartesian form and pi 2 is given in vector form. We now know that the cosine of the acute angle between the two planes can be calculated by taking the magnitude of the dot product of the two normals and dividing them by the sides of two individual normal lines. We can easily find the normal to pi 1 based on the coefficients of x, y, and z, giving us components of 1, -3, and 1. We can find the magnitude of this normal by taking the root of the x component squared plus y component squared plus the z component squared, and once we do that, we will get root 11. Sadly, we don't have the normal to the second plane, but we can use vectors b and c because we know those are parallel to the plane, and we can do a cross product on them in order to find the normal. We're going to use our diagonal multiplication to do this. So for the x component, we're going to do 1 times 1 minus 3 times 0. For the negative y component, we're going to do -2 times 1 minus -1 times 3. And for the positive z component, we're going to do -2 times 0 minus 1 times -1. We'll end up getting 1, -1, and 1 for the x, y, and z components of the normal to the second plane. The magnitude of this is going to be root of its x component squared plus y component squared plus z component squared, which will give us root 3. We need the dot product between the two vectors as well. So we're going to take the dot product of 1, -3, 1 and 1, -1, 1. We're going to multiply their x, y, and z components and we're going to sum them up. So we're going to have 1 times 1 plus -3 times -1 plus 1 times 1. And that will simplify to 5. Now we can use this information to find the acute angle between our planes. So cosine of theta is going to equal to the magnitude of the dot product. That value is 5. And we're going to divide that by the magnitude of the normal vector to plane 1. That's root 11. And also by the magnitude of the normal to plane 2, which is root 3. This simplifies to 5 over root 33, and we can use the inverse cosine function on our calculator to get theta as approximately 29.5 rounded to 3 significant figures. I have prepared one question with 3 parts for you folks to try out on your own, and I will try to post a solution to this in a separate video as soon as I can. I hope that this video was helpful in giving you an idea about how we can calculate the angle between a line and a plane, and how we can calculate the angle between two planes. Thank you for watching.